All right. Let's say that I'm in my car and I'm driving my car up and down Bulldog Lane. For the sake of this exercise, we are going to assume that Bulldog Lane is absolutely straight from Highway 15 all the way up to the baseball field. What we're going to do is we're going to graph the position of my car in relation to how much time I have been driving. You'll notice the x-axis here goes up to 60. So that's going to be my time, and the y-axis is going to be my position in relation to my position. Position in relation to how much time I've been driving. So we're going to start the truck at the forum, which we're going to consider x equals 0, right down here. All right. So any distance x is measured as how far I am from where I started. Any distance we measure on the y is how far I am from where I started. Not necessarily how much total I've driven, just how far I am from where I started. So that might have been confusing, but hopefully it'll make more sense when we start this scenario. All right, so I'm starting at 0. I'm going to drive, starting at the forum, x equals 0. I drive 500 feet to the high school, and that takes 6 seconds. So first, I'm going to take our line. We're going to move it up to 500, and that took 6 seconds. So 6 seconds on the x-axis, I've moved 500 feet. I'm at the high school. All right? Next, I put my truck in reverse, and I go back to the forum. This takes me 10 seconds. Oh, it changed that line. All right, so I'm going to take my car, I'm going to put it in reverse, and I'm going to go back to the forum, and it's going to take me 10 seconds to do that. So if it takes me 10 seconds, that means it's going to be back at 0 at 16. I'll move that. That should start right there. You get the idea. So what's my position now? Well, my position is 0. Why? Because I am 0 feet away from where I started. That doesn't necessarily mean I've moved 0 feet, but remember, this is a position in relation to where we started, and we've been going for 16 seconds. Let's keep going. I drive up 1,500 feet to the football field. This takes me 20 seconds. All right, so 20 seconds, that's going to be 36, and I'm going to drive 1,500 feet. So we need to move this up to 36 and 1,500. Good. That should connect down there. So after 36 seconds, I am 1,500 feet away from where I started. Now remember, it looks like we're like going up and down mountains, but we're not, right? This is where right here is where we started. We drove up to the high school, and then we drove back, and then we drove up to the baseball field, right? This is just position in reference to where we started. I'm 1,500 feet away from the forum at x equals 0. I'm going to drive the remaining 500 feet to the parking lot behind the football field, and this is going to take me 4 seconds. So I need to move up here. And if it takes me 4 seconds, then that means it's going to be at 40. So 2 lines at 2,000. Go all the way up to the top there. Connect those lines. So now I am 2,000 feet away from where I started, and I've been going for 40 seconds. Lastly, I'm going to back my truck up 1,000 feet to the parking lot behind the school, and this takes me 15 seconds. All right, so I'm backing my truck up. We're going to go this way. So if we're at 2,000, we're going to go down. Sorry. We're going to go down to 1,000, and that needs to be at 60. So my window's not big enough. Let me make sure. Okay, I got to go all the way over. So it finishes there. Make sure that that connects. All right. So what we're seeing here is my position. And where is my position in relation to where I started? Well, let's look. We finished here at the y-axis, and that's at 1,000. So I am 1,000 feet away from the forum. That's what that means. I backed up from the parking lot behind the baseball field, and I'm now 1,000 feet away from the forum. Have I traveled only 1,000 feet? No, I've traveled all this. I went forward, then I backed up, then I went forward, then I went forward again, then I backed up again. And so that does not represent how far we've traveled. It represents how far away from where we started. how does the graph behave when I am driving backwards? I'm going to let you think about that for a second. What's the graph doing when I'm driving backwards? It's going down. What that means is that the distance from where I am to where I started is going down, right? We drove up to the high school, and then we drove back down to the forum. So anytime I'm going backwards, the graph is going down. Let's say I started at x equals 0. Let's say that instead of driving up to the high school, I took my vehicle and I backed it up to Highway 15. What would that look like? Think about it for a second. It would look like it would actually go under the x-axis. Why? Because if the forum is x equals 0, then anything behind the forum, in this case Highway 15, anything on the other side there would be negative numbers. So we would go under the x-axis because we are negative distance from where we started. Okay, so let me give me a second to get rid of all this stuff. This is one of the most important applications. Actually, you know what? I'm just going to get rid of this and then open it up again. This is one of the most important applications of calculus. It's called motion, all right? And motion in calculus exists on 3 levels. Let me draw this real quick. One level, 2 levels, 3 levels. Okay, so the first level is position. The definition of position is where an object is in relation to its initial position. Oh, sorry. Make space there so you can see it better. It is usually given, the unit for position is usually either feet or meters. And it's often written as S of t. That's often how you see it. That's often how it's denoted there. And instead of x, it's t now because t is time. So that's the first step. Now, the second step, in fact, the derivative of position, but we'll get more into that in a second, is velocity. And velocity is defined as the rate, the rate at which position is changing in a certain direction. And the unit for velocity is either feet per second because it's a rate, right? Velocity is the derivative of position. It's a rate of change. Or meters per second. It doesn't have to be feet or meters. It could be miles, and it doesn't have to be seconds. It could be hours. It's just usually what it's given us. And the last step is acceleration. Acceleration is the rate at which the velocity is changing. And you can put it under it, but I've run out of room. So that is given as feet per second, or I can't write it on here because I don't have the notation. Well, I'll write it on the side actually with my pen. It's more commonly stated as feet per second squared. And real quick, I forgot to make the what velocity and acceleration are usually seen as. You usually see that written as v of t, and you usually see that one written as a of t. Make sure you're putting all those under that stairs. And what you got to remember here, the important thing is that velocity is the derivative of position, and acceleration is the derivative of velocity. All right. So last thing we're going to do is I'm going to give you a position function, and we're going to take the derivative of it to find the velocity together. So give me a second. Let me get this pulled up. Okay. So let's say that a object's position is given by s S of t equals t cubed plus 2 root t minus 1 over t. That's its position. That represents the distance from where the distance between where it is to where it started. I want to find the object's velocity. Well, if I have the position function and I want to find the velocity, that means I've got to take the derivative. All right? So we're going to take the derivative of this position function. Now, before I do that, I'm going to rewrite this position function so that it's easier to take the derivative. So t cubed is okay. Instead of root t, we're going to make it t to the 1/2. And instead of negative 1 over t, we're going to make this negative minus t to the negative 1. Now we're going to take the derivative of it. So we could put s prime of t, because it's the derivative, but we know that velocity is the derivative of position. So instead, I'm just going to put v of t, and that's going to be 3t squared. 2 times 1/2 is going to be 1. 1/2 minus 1 is plus t to the negative 1/2. Negative 1 times minus is going to be plus t. Negative 1 minus 1 is negative 2. So there is the velocity. Oops, sorry. That is the velocity function, the derivative of position. Now, what we want to do, and you should write this down, we're going to find the object's acceleration. We're going to find the object's acceleration at time 2. Excuse me, at time t equals 2. So what that means is that we need to take the derivative again because we have velocity. So, a of t equals 3t squared. Derivative, 3 times 2 is 6. 2 minus 1 is 1. So, derivative of 3t squared is 6t. Minus 1/2 comes down. Negative 1/2 minus 1 is the negative 3/2. And then plus 1 times negative 2 is going to be minus 2. T, negative 2 minus 1 is to the negative 3. But we're not quite done, right? We've got the acceleration, but I need the acceleration at time t equals 2. So what I'm going to do is I'm just going to plug in 2 for t. So that shouldn't be negative. Ignore that. It's not there. A of 2 equals 6 times 2 minus 1/2 times 2 to the negative 3/2 minus 2 times 2 to the negative 3. And you all could probably do this, but for the sake of time, I'm just going to go ahead and simplify it. You got 6 times 2 is 12. You bring that 2 to the negative 3/2 down to the bottom and simplify it. You're going to end up with negative 1 over 2 times the square root of 8 minus 2 over 8, because that 2 to the negative third comes down. And then we would simplify, but for the sake of time, we're not going to quite do that today. So the acceleration of whatever this object is at 2 is this. Oh, and we would need a unit, so it would be feet per second squared or meters per second squared, something like that. So really, guys, all we're doing here is taking the derivative. We're just calling it something else. Tomorrow, or the next class rather, we're going to get into a lot more specifics of this. But right now, all you need to know, the big things, are that position is the initial function, velocity is the derivative, acceleration is the derivative of velocity or the second derivative of position. And that we can plug values in to find position, velocity, acceleration at any one point.